Hello, welcome to the second part of our discussion on continuous probability distribution. So far, we've looked at continuous uniform probability distributions, how to find the probability, the mean, and the standard deviation. We've also introduced you to normal distribution, and we've spent some time to look at how we can calculate the probability of a normal distribution using just two steps: standardization and using the standard normal probability table. To continue with our discussion here, I would like us to look at another scenario of normal distribution. What we're going to look at now is we're going to look at the case where we know the area of the normal distribution, the area under the curve, but we want to find the value of x, or the value that actually gives us the area. Let's discuss this with a very simple example. So given that the mean of a distribution is 15 and the standard deviation is 6, how many gallons will be reordered in the lowest 95%? And so we know the area to be, or the area to the left of the curve, is 95%, which is a proportion of 0.95. What we want to know is the value, or the number of gallons that will give us the area 0.95. Let's look at how we will do this. So this also follows a two-step approach. The first step is we're going to look up from the table, and it's basically a reverse of what we did before. But we're going to look up the table and find the value of z that corresponds to 95%, or 0.95. And then once we find that value of z, we will rearrange the standardization formula to find it. So this also looks at two steps. Step one, we'll find the value of z that cuts off the area of 95% to the left, or 0.05 in the right tail of the curve. How do we do this? We go to our standard normal probability table. In our standard normal probability table, we are going to look up the area from the standard normal probability table that gives us 95% to the left. Now, what you want to do is you want to look at this section of the table, and we want to find 95% on it. So over here I have 0.94950, 0.95053. This seems to be more closer to 0.95, and so I'm going to use this value here. Now, what value of z gives me this area? The value of z that gives me this area is 1.65. 1.65. So when these two intersect, I get is the area of 0.9503. Now, somebody will also say, can't I use this? That is totally fine, because if you run this to the nearest two decimal place, it also gives you 0.95 as well. And so on this row here, we could use any of these, and that should be okay. But I'm gonna go with 1.65 because that is the closest to 0.95. Okay, and so 1.65 is the value of z that gives us the value, or the area of 95%. So I find the 1.65, and the next thing I'm going to do is I'm going to rearrange the formula to find the value of x. Now remember, in our first process when we were finding the area under the curve, we standardized with z equal to x minus the mean over that. And that was when we were finding z. This time we want to find x, and so we will rearrange this formula. And when we rearrange this formula, the formula that we will use to find x will actually be equal to z times the standard deviation plus the mean. Now, from the question, we know that the mean is equal to 15, the standard deviation is equal to 6, and so knowing z is now 1.65, I'll just go 1.65 here, the standard deviation, which is 6, plus the mean of 15. Now you notice that in the example, I use 1.645, which is closer to, but you can use any of that from the table. Whichever one you feel is closer to 0.95%, you can use that, and that should not give you an extremely different answer. And so I'll multiply these two first, which will give me the multiplication of 1.65 times 6, and then I'll add the 15 to it to get a value of 24.87. If we round it off to the nearest whole number, that is 25. So what we are saying is a reward point of 25%, 25 should give us 0.95 to the lower tail, and by with the complement rule, 1 minus 0.95 will give us 0.05 on this side here. And so that is how we determine using what we call the inverse function to find the value of x for a given area under the curve. Now, if you have the recommended calculator for the course, you can also use the inverse norm function to do that as well. So let's take a look at a practice question here. In a certain university, entry to a certain university is determined by a national test. The score on the test is normally distributed. So this tells us we are not dealing with any kind of distribution, but a normal distribution. The mean is 500 and a standard deviation of 100. Tom wants to be admitted to university, and he knows he must score better than at least 70% of the students who took the test. Tom takes the test and scores 585. Will he be admitted to this university? So first of all, we're looking at a normal distribution. So we create a normal distribution curve. You don't have to do it. I'm just creating it for illustration's sake. The mean of this normal distribution is right here at the center, and the mean is 500. The standard deviation we know is 100. What we don't know is that the value that gives us at least 70% less, and so we're looking at value of x such that 70% or 0.7 will be less than that. So we already have the area given to us, and the area is 0.7. How do we find the value of x? Again, we will use the table to find the z value for 0.7, and then we will use the formula x equal to z times the standard deviation plus the mean to find the value of x. Try your hands on this, and when we meet for our discussion, we will practice this as well. Now, another way we can also calculate normal probabilities is to use the norm.distribution function in Excel and the norm.inverse function in Excel. Because this course doesn't come with a lab component, I'm not going to spend time on how to do this in Excel. But if you have time, you can import your data set into Excel and use these two functions to find the normal distribution probability for a certain data set and the inverse norm approach to calculate the value of x for that data set. Okay, so let's close off our discussion here by talking about the last probability distribution, which is exponential probability distribution. Now, what is exponential probability distribution? It is also another probability distribution used to describe continuous random variables. But with exponential distribution, we are looking at the time it takes to complete a task. The time it takes to complete a task. Let's look at some examples of random variables that follows exponential distribution. For example, the time between vehicle arrivals at the toll booth. How long will it take between the first car moving and the second car moving through the toll booth? And so here we are looking at time between two events. Let's say a person goes in to complete a questionnaire. Exponential distribution is looking at the time it takes to start, the time it takes to end, the interval between that two periods. Or let's say I go shopping, grocery shopping, like I always do. An exponential distribution will look at the time between I arrive and at the time that I leave. How long did it take for me to be served at the counter? And so that's what exponential distribution is looking at. Now, a property of exponential distribution, like all the other distribution, is the mean and the standard deviation. The good news is the mean and the standard deviation for an exponential distribution are the same. Just like Poisson probability distribution, the mean and exponential distribution are the same. An exponential distribution is skewed to the right, and so whenever we sketch an exponential distribution, this is how it always looks like. So like we've been doing for the other probability distribution, let's look at how we calculate the probability for an exponential distribution and then how we find the mean and standard deviation. This is the probability density function, but what we want to do is we want to use the probability distribution function. And so we will be using this formula here to find the probability for an exponential distribution. What is the formula saying? 1 minus e, and e is a constant, okay? It's a value that never changes, and the value of e is 2.71828. So the formula to find an exponential distribution function for a certain random variable that follows exponential distribution is 1 minus. So if I'm to translate this formula, it's actually 1 minus 2.71828 to the power of the value of x divided by the mean, negative x divided by the mean, which means for our exponential distribution case, we will give you the value of x, that is the time between arrival and departure, the time that a service is rendered, divided by the average time. Let's look at some examples on how we calculate the mean. So the time between arrivals of cars at AI's full service gas pump follows, again, take a look, an exponential distribution. So we tell you the kind of probability distribution we're looking at. Here is an exponential probability distribution. And so that tells you this is the formula for finding the probability. Follows an exponential distribution with the mean time between arrivals of cars to be 3 minutes. AI would like to know the probability that the time between two successive arrivals will be 2 minutes or less. So the x is equal to 2 minutes. And so we're looking at the probability that x will be less than 2 minutes. Again, our formula is 1 minus e to the power negative x over the average. And we already know e to be 2.7, let me reference that, 1828 to the power of negative x, and x is equal to 2 divided by the average, which is 3 minutes. And so to solve this, what I'm gonna do is I'm gonna first of all find 2 to the power 2.71828 to the power negative 2 over 3, and then I'll subtract my answer from 1. How do I do that? When I find 2.71828 to the power of negative 2 over 3, it gives me 0.5134. I subtract that from 1, and this is the probability I'm looking at. 0.4866. So there is a 48.66% chance that the time between two arrivals at an average of 3 will be less than 2. Take a look at a practice question here. I want you to spend some time and work on this practice question. When we meet, we will discuss it. But the number of days ahead travelers purchase their ticket can be modeled by an exponential distribution. The average amount of time equals 15 days. Find the probability that a traveler will purchase a ticket fewer than 10 days in advance. And so our x is 10, our mean is 50. We put it in the formula and we find the probability for this exponential distribution. Try your hands on this. But somebody will say, isn't this the same as Poisson distribution? Very similar, but not the same. You see, with Poisson distribution, we are looking at how many cars will arrive at the toll booth. For example, in an interval of 30 minutes, how many cars will arrive? But exponential distribution is looking at how long will it take between two cars' arrival. And so one is looking at the number of occurrence, the other is looking at the time between two occurrences. And so Poisson is discrete because we are counting the number of cars that will arrive at the toll booth. Exponential is continuous because we are measuring the time between two cars. Okay, so know the difference between these two. One is discrete, the other is continuous. Thank you very much. We will discuss further into this later in the next video. Okay, bye-bye.